I'm Espen from Prediktor. So Prediktor is a Norwegian-based software company. We've been an OPC Foundation member since 1997. So we became the first member of the OPC Foundation back in the days. In the early history of Prediktor, we have been doing more or less everything within industrial software across many different industrial segments. 4 years ago, we had a new ownership coming into the company, and we decided to focus on the energy sector. Hence, also on OPC UA, we've been focused on energy. And it's been exciting 4 years in the energy sector. So like 4 years ago, when we entered this or decided to focus, it was all about assuring that we can create a new sustainable energy sector across the globe. But recent events, the last few years, has also, you see, especially in Europe, that sustainability is not the only important parameter for energy. We also need affordable energy. At least in Norway, we see extremely rising prices the last few years for consumers and everybody. And we also saw in Central Europe, there was a challenge with energy security of supply. So these are aspects that come in that also affects what needs to be done within energy. But first, since I'm here now in Tampere, I'm very glad to be back here. I was a software engineer back in 1999. So we had 2 years been developing our OPC Classic tools. And we were installing our software in this vessel here, Voyager of the Seas, that has recently been built on Masa yards, now called Meyer Turku. And of course, there was a lot of challenges. They were cutting power, running sea trials and everything on this ship. And we had a software system that collected data over OPC Classic and with a high-speed logging to a Windows NT machine. And cutting power and doing things like that created havoc in our system. So we were having a lot of discussions with Neles Automation. So I had a lot of communication with a guy called Kimmo Kente here in Tampere, and we went back and forth between Turku, where the facility was, and the offices here in Tampere. So long email discussions back then, a couple of 20 years ago, about the challenge. But eventually, we got it all fixed and settled, and it was a success. But the client, Royal Caribbean Cruise Lines, wasn't pretty sure if everything was all right. So we had to send one of our senior engineers with the first Virgin Voyage trip from Turku to Miami, where the ship is going to sail. And they didn't only test the various technical facilities at the time, they also tested the kitchen. So we came back 10 kilos heavier as compared to when it went up. Okay, back to energy. Energy has been challenging, but right now I'm going to present 3 great news to you through this presentation. So first amazing and great news came only 2 days ago from Wall Street Journal. So over the years, the analysts have tried to forecast how fast we will actually transit to renewables and how fast we will build out renewable technologies. And they continue to fail in anticipating the pace of the growth. So the analyst here for solar capacity in 2010, they forecasted this in 2020 like this, but now actually the latest forecast is like this. So the build out of renewable technologies, solar, wind, and also EVs and batteries is exploding. So this is totally amazing. And you can also see the opposite on the more challenging energy generation, coal generation forecast. The projection here from the analyst was like this, but actually it's been like this. So you can say that the industry keeps over-delivering on actually the energy transition, putting more sustainable renewable energy assets out there. And this is continuing and it's exploding. And related to this, is the second great news item. Only a little more than a month ago, we had this news coming in. Largest offshore wind farm celebrates power milestone. So they put power on the largest offshore wind farm that's been built so far. A little video talking about this one. There's no sound? Yeah, no sound. Could we get the sound a bit up?
UK waters. It is divided into 3 phases known as Dogger Bank A, B, and C, with a total planned capacity of 3.6 GW. This ambitious project, led by SSE Renewables in collaboration with Equinor and Krogh, represents a testament to the remarkable potential of offshore wind energy. The momentous accomplishment of producing the first electricity from the Dogger Bank wind farm has been made possible with the installation of the first of 277 turbines. These turbines are of GE Vernova's Halley 8X 13MW variety, and they are amongst the largest and most powerful wind turbines in the world. Each rotation of the 107-meter-long blades of these turbines is capable of generating enough clean energy to power an average British home for 2 days. The development of the Dogger Bank wind farm is not just about clean energy, it is about building a more sustainable and prosperous future. The project is expected to create long-term employment opportunities, stimulate economic growth, and strengthen the security of the UK's electricity supply. It serves as a testament to what can be achieved when policymakers, investors, industry leaders, and communities collaborate to accomplish remarkable feats. The world's largest offshore wind farm, the Dogger Bank, is an international endeavor. It showcases the potential of offshore wind energy and highlights the significance of global collaboration in achieving renewable energy goals. SSE Renewables, Equinor, and Krogh, in their joint efforts, have set an example for the world, illustrating the potential of offshore wind energy projects to make a profound impact on the fight against climate change and the pursuit of clean energy.
As I will show you towards the end of this presentation, the core underpinning data communication technology here is OPC UA in this joint project. It's also an example of collaboration across many segments, across vendors, etc., to get this in place. So this single industrial asset spans like 40 by 40 kilometers, same size as the Greater London, and it will provide electricity to 10 million UK homes. So what does that, 6 million UK homes. So this is the same as the combined number of households in both Norway and Finland. So this single asset could power up all households in Norway and Finland with renewable energy. It's an amazing project. So, but it's not the only one. I picked up some numbers from a database that we have access to. The Energy Industry Council updates a database with all known energy projects coming up. So this is not historic installed, these are the ones coming. So in offshore wind, there are 900 offshore wind projects in this database with 1,000 gigawatt, about 300 Dogger Bank type of projects in this database. You have 1,800 onshore wind projects, 500 gigawatt. 3,000 solar PV projects, 900 gigawatt, and 900 energy storage projects, 300 gigawatt. So all of these are projects with committed operators, committed suppliers that are planning to build industrial scale big assets. So there's an enormous amount of industrial assets going to be built now around this. And to compare this, what does this mean in terms of gigawatt? You can look at Germany. Germany is one of the nations with the most renewable energy capacity in this. So they have more than 50% of wind and solar and total capacity of energy from renewables. And if you sum all of this together, you will find that the planned project is 10 times what is already existing capacity in Germany. So actually, we can power up 5 countries like Germany with a planned project portfolio within renewables, and it's coming online in the next years. But all of these operators that are now putting up all of these projects, they will all face a significant challenge, and the challenge is that the only thing they can compete on, and they need to compete on, is taking down cost. If you look at the development of levelized cost of energy, this is the cost per kilowatt hour, calculated both with CAPEX and OPEX through the life cycle of the asset. You'll see that this comes down. This is a 10-year history of this. It continues to come down both on offshore wind, onshore wind, and solar. So if you're an operator, you need to find a strategy how to be there to take down cost every year, continuously. If you don't do that, you will be outcompeted. You will be out of business. So it's like the car industry, more or less. You need to be there optimizing every year. And of course, I think many agree that in order to stay profitable with the fierce competition, you need to become the master of data-driven operations and ensure you're going completely digital. And data-driven operations, well, I know we are all into this and in this seminar here. So we have the idea that a lot of data is streaming out from the sensors or the various power assets. We're going to plug them in to a lot of digital tools and smart applications. And then based on things we see there, we will have new innovations and run the assets even better. But if you don't take special precautions, this is rather difficult, right? Mutual understanding semantics is needed here. And of course, the concepts involved and needed is that we have these existing investments or new assets coming on with numerous critical plant systems from a wide range of suppliers. And often it's little or unplanned semantics or definitions of the data in those systems. And then we have the ambition to install the new innovations, continue to innovate, install this, roll it out across the asset portfolio, the smart applications that will assist us in taking the cost down and running the assets more optimal. But what we lack is a standardized context with type object and information models, and also an open protocol that can service this, cyber secure and robust. But for all of us here in this room, we know that there is definitions already existing in the industry. The International Electrotechnical Commission, IEC, has already made a lot of definitions usable across a lot of industries that we can look into to find the right semantics. And of course, we have the OPC UA protocol. So this example here is from the wind industry, where everything that describes the structure of a wind asset is set up there in the IEC 62400 and building on top on 61850. And OPC UA is, of course, the protocol that can host any type of information model, regardless of other origins, and provided through the OPC UA APIs in a robust and reliable fashion. So what the missing pieces we now have in the energy sector are those companion specifications that can be used. So the companion specification is, of course, the combination of some kind of usable standardized context and map that to the OPC UA information modeling concepts. So that's what the OPC UA Energy is all about. And is this an interesting challenge? I would say so, to do this, because the integrated industrial grids represents the biggest industrial systems that have the challenge with interoperability in real time. So we're talking about thousands of generators, we're talking about a multitude of transmission and distribution systems, and thousands of consumers integrated in one giant industrial system in many places in the world. So this is one of the most complex interoperability challenges, and it's also one of the most important ones, because when you're taking all of those new projects now and putting them online to the grid, it's going to be chaos if you don't do this in a controlled manner, right? So we need to assure that we have the right standards, etc., to use when we go about and deploy all those new assets in order to secure a good and efficient energy transition. The third good news then is that OPC Foundation understands its role in this. And I'll now go with full force with a lot of the member companies into this. So I think almost 2 years ago or 18 months ago, a lot of people, including Erich Barnstedt, Chris Munch, and me, had at the same time an initiative. We need to get some standards in place. And Stefan did a lot of work trying to get various types of other organizations on board, like OSTU. We didn't succeed immediately with OSTU, so we decided a year ago we need to go out and establish these standardization activities from the origins of the OPC Foundation members. So that's what's been happening in 2023. So we have the wind power plant type of companion specification. I'm chairing this one together with Bertram Lange from Bachmann. History on this is that there was already a group formed called IC 61400-25 user group that was on the way of actually creating a standard for the wind power plants. They had a bit challenge in getting pace in the activity, and at the same time, Equinor Prediktor had already produced a companion specification installed in the Dogger Bank, etc. So we had the idea we could join forces. So that's what we done. And we come pretty far now, and we hope to have a draft of the specification published before Christmas. Then we have carbon capture and storage. It's chaired by Erich Barnstedt in Microsoft. It's almost a year now in activities in this group, and they also come pretty far in starting to drafting the specification. Then we have the power consumption that started more than a year ago, and this comes from VDMA. So this is one of the activities and the large set of standardization activities. I know we will hear from Christopher later today. And it's about consumption of energy, not generation. And there are other activities pending what is happening in the other activities, because we need to harmonize. I will talk about that. So the hydropower plants, there are both companies and people in the wind power plants very interested in getting the hydropower plants running. And we have oil and gas and battery energy systems also pending or actually establishing a work group to form the companion specification. But we have in place now also an energy harmonization group that will assure that we will not do the same thing many times in the various types, because we have repeating type of equipment in many of these energy domains, and we will put that into one core specification that the other ones will rely on. So for those of you interested in energy sector knowing about the IC standards, we're thinking about having an IC 61850 basis for all the energy standards. There's been one already published in 2018 that was a release candidate. But unfortunately, this 61850 release candidate didn't use the core concepts in the OPC UA parts. So it needs to be revised in order to make it useful for the generic OPC UA clients. So that's what we're doing. And then 61400-25 on top of this for the wind power plants. For solar PV, we have 61850-4-720 as the semantic standard from the IC committee. And we have for the hydropower plants, it's the 61850-4-710. So, but the core important part is to get the 61850 in place. Once we have this in place, all the rules for actually doing the mapping from the IC standards will follow suit for the other standards as well. So I believe we will have a pretty rapid production of the other ones once we have the 61850, the right one, in place. So the most of the activity for the 61850 based standardization activities goes on now in the wind power plant group. And it's a collaboration with OPC Foundation and the 61400 user group. And this is a significant set of companies. It's both the operators within wind, it's the equipment providers, the turbine providers within, it's the automation providers and software suppliers within wind. So you will find all of them in this group. And I would say it's an interesting type of collaboration, because I would say that I think more of the pragmatic type of approach and the companies come from the OPC Foundation, typically like Equinor, Kongsberg, Prediktor. We have project deadlines to meet, we need to get something in place. Whereas the people from the IC committees tend to be more formal. But I think it's a good mix. You have the pragmatism and the formalism in combination here. Yeah. But let's go back to the Dogger Bank, and because the Dogger Bank now has an early version of this new standard already in place when it's powered up. Equinor is the operator of Dogger Bank on the top side here, whereas SSE Renewables, the giant UK utility company, is responsible for many of the systems down on the plants. So this is the architecture. There's a lot of plant systems, and all of these plant systems will have real-time data streams. Most of these are already OPC UA. But then we have a gateway that does the job of actually organizing, taking all the unplanned type of semantics from all the plant system, reorganizing them, assuring that everyone adheres to one specific standard that will be the OPC UA for wind power plants. So all in all, this is more like 3 sub-sites in the Dogger Bank. So it's 3 times 150,000 variables, a total of 3 times 240 samples per second in this system, both real-time data, time series, and alarms and events, and everything contextualized and standardized with the wind power plants semantics. And of course, the benefit of this for a company like Equinor is that when they look at this from the portfolio, from the enterprise side, they will see kind of like the same digital skin across the enterprise, independent of who's the supplier, who did the commissioning, et cetera, et cetera. It's the same semantics, and this enables, first of all, using OPC UA, the highest type, the best type of quality and security for the portfolio. And when you have standardization of semantics, you also enable artificial intelligence and ML strategies. And you can also scale out new functions across the portfolio much more efficient, because once you do it one place, it's the same setup everywhere. And of course, what is also happening in the energy industry with all those projects is a large scale of asset play. Somebody will sell their assets, somebody will buy new assets, and you need to get those assets into the enterprise ID strategies. So also having this standardization type of activity using the same digital skin, also new assets when you get them in, will assist you. So with this, they can take down cost by moving activities on site to a central site, taking cost down from the operations on the local site. And of course, you will have centralized analysis team working all the collected data and establish best practices for the operations team and invent new methods that you can deploy to supervise all the complete asset portfolio with AI and ML. So that was the introduction of OPC UA for energy. I think we will have a lot more technical information to you next time when we have produced some of the component specifications. But for now, it's more on the ambition. And actually that there's still some pending activities. I know there could also be interest in companies in Finland to join those. And that would be great. We need both operators, suppliers, equipment into those standardization activities in order to do it the right way. It doesn't make sense to establish some of these standardization activities unless we have the domain expertise into the activities. I will talk more about what Prediktor does towards the end of this seminar in another session, so we can come back to that at the time. Thank you. Yeah.